Hello, my lovelies. It's Susanne, and today I want to show you how to solve this problem that was part of the German Abitur. In Germany, you have to pass a final exam at the end of high school, and this problem here was part of the section where you were not allowed to use a calculator. Usually in this section they ask basic stuff, so let's take a look at it together. Given is the function f that maps x to 8x to the power of 3 plus 3x defined on the real numbers with derivative function f prime. Part A. Calculate f prime of 1. We will take a look at part B later. First, let's calculate f prime of 1. First, we need to know our function f, so let's start with f of x. How does our function look like? This way of writing might be a little confusing, but it just tells us this thing here is your function. This is your f of x. So we take our 8x to the power of 3 plus 3x and we'll work with this. To be able to find f prime of 1, we first need f prime of x, so the derivative of this function here. How can we differentiate this function? The rule is that we start here, we take the exponent and multiply it by this number here. So 3 times 8 equals 24, and then you decrease your exponent by 1. So instead of x to the power of 3, we only have x to the power of 2. Then we have our plus, and here this is a special case because here's only x in here, so x to the power of 1. Then the fast rule is that the x will vanish and only the 3 is left here. Okay, this is our derivative, and we are looking for f prime of 1, so we are not yet done completely. We still have to insert the 1 now for our x. So for every x we can find here, it's just here, we have to insert the 1 and calculate this then. So we have 24 times 1 to the power of 2 plus the 3. 1 to the power of 2 is just 1, 24 times 1 is just 24, and 24 plus 3 is 27, and this is our result of part A. Part B. Determine an expression for the antiderivative f of f whose graph passes through the point -1, 5. This is still our function f of x we're working with here, but this time they want us to find the antiderivative, capital F, of our function, not the derivative. But they don't want us to find any antiderivative, they want us to find a special antiderivative, the one that passes through this one point here. And to be able to find this one special antiderivative that really passes through this point, we first have to find all possible antiderivatives, capital F, of x first. How can we find them? Well, the rules are reversed now compared to part A. This time we take a look at the exponent, but this time we're going to increase it. So instead of x to the power of 3, we're going to have x to the power of 4. Then we will have a fraction here. We take our new exponent, the 4, and write it here as the denominator. And the numerator is going to be the number that was in front of my x here. So the 8 goes on top here. Then we have the plus, and the same rule here. We have x to the power of 1, so we increase our exponent, so we have x to the power of 2. Then in our fraction, we take the new exponent, the 2, write it down here. And on top, we take the number that was in front before, the 3 goes here. And then to get all possible antiderivatives, we also have to add a constant c. C is just a real number, but these are all possible antiderivatives of this function here. Maybe we simplify this fraction here because 8 over 4 is just equal to 2, so this looks way more friendly here. We can't do anything here, so this is the version I would work with from now on. And as I said, because of this c, these are all antiderivatives, but now we want to find our special one that passes through this point, so we have to find a special c. If we want to use this point, such a point always consists of an x coordinate and a y coordinate. And this function here should pass through this point, so we can insert the -1 for x. So we have x here and x here. And we can insert the 5 for the y coordinate, which is just my capital F of x. So this is my y. And I insert the 5 here and the -1 for the x, and then I will find my c. So instead of my y here, I'm going to insert 5. Then on the other side, I have 2 times. Instead of my x, I insert -1, so in parentheses to the power of 4 plus 3 over 2 times. Instead of my x, I insert -1 to the power of 2 and then plus c. And now we only have to solve for c. So let's calculate this here a little bit. We don't have a calculator though, so where do we start? Maybe here, -1 to the power of 4. Because this is an even exponent, the result is going to be positive. So we have a +1 here. So in total, 2 times 1, which is just 2 for all of this here. And here the same, -1 to the power of 2 is going to be +1. So we have 3 over 2 times 1, which is just 3 over 2. Okay, maybe let's bring both numbers to the left side by subtracting them. So -2 here, -2 also on the other side, and also subtract the 3 over 2 here and on the other side as well. The right side, maybe let's start there. It's easier. This cancels out, and only our c is left. And here we have 5 minus 2, which equals 3, but then we also have to subtract the 3 over 2. Let's convert this into a fraction as well. So we have 3 over 1, but we need the same denominators. So let's multiply by 2 here. 1 times 2 equals 2. The same here. 3 times 2 equals 6. So now we can subtract. We have 6 minus 3, which equals 3. The denominator stays the same. And this is our c. It's 3 over 2, so we can insert it here. For our c, we write 3 over 2. And this is then the special antiderivative that passes through this one point here. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!